Hi everyone, welcome back to the second video. In this video, we will be covering the topics of classes, objects, methods, and constructors. So here I have some code already. So let's just go through what this code does. So the code is for a banking system, and here I have two bank accounts, 1 and 2. So the first bank account is Alice's account. The account number is 1234 and her balance is $500. And account number 2 is Bob's account. His account number is 5678 and he has a balance of $300. Now here I also have two functions, one to deposit money into the account and one to withdraw money from the account. So let's go through each of those functions as well. So the first function has 4 parameters: the account name, the account number, the current balance, and the amount that you want to deposit into the account. So what the function does is it prints out the name, the account number, and the amount that was deposited. It then calculates the new balance by just adding the current balance and the deposit amount, and it prints out both the old balance and the new balance. And lastly, it returns the new balance, and the reason for this is so that we can get the new balance from the function and store it back into the variable for that account, the balance variable. Then we have a withdraw function, which is very similar. It also takes the name, the account number, the balance, and the amount as parameters. And it prints out something similar, but it prints out that they withdrew this amount. And it calculates the new balance by subtracting instead of adding, since you're withdrawing from the account. But here things become a little different, because if the new balance is less than 0, then you're not allowed to withdraw such an amount. You cannot withdraw more than you have. So if the new balance is less than 0, then it will print out that we cannot withdraw, and it will show the original balance since the withdrawal did not go through, and it will return the original balance since the balance didn't change, since the withdrawal did not process. But otherwise, if the new balance is not less than 0, it will print out the old balance and the new balance, and it will return that new balance so that again we can store that new balance back into the variable. So first, let's run these functions. So we first run the deposit function for Alice, and she deposits $400 into her account. And when we run the function, we have to store the new balance back into Alice's balance variable, which is why we must return the new balance in the functions. So Alice deposits $400. Alice then withdraws $700, and again we store the new balance back into the variable. And then Bob withdraws $600, and again his new balance is stored back into the variable. So let's run the program and see what happens. Okay, so we can see Alice deposited 400, so her balance went from 500 to 900. She then withdrew 700, so the balance went from 900 down to 200. And then Bob withdrew $600, which is more than he has because he only has $300. So the program says that he cannot withdraw and that his balance is still $300. Okay, so there are a few issues with this program, although it seems to work pretty well. The issues are not in terms of it working or not. The issues are in terms of how complicated it is. So the main problem with the program right now is that each bank account has 3 variables, which might not seem like a lot, but in a real banking program, we might have many other variables in here, such as the person's address, the person's credit card number, the person's date of birth, their salary information, their tax information. We'll have, if we had to store all of these, we would need a separate variable for all of them, which would be a lot. We would have maybe 10 or 15 variables for each bank account, which isn't a very sustainable thing to have. So there are ways to get around that to simplify these sorts of situations. And in the last video, we already saw one of those ways, which is to use a tuple instead of having a separate variable for all of them. So instead of having an account name, number, and balance as 3 different variables, we could have a tuple which stores all 3 of those variables. So we would have a tuple for Alice's account and a tuple for Bob's account. So let's actually convert the code into the form which uses a tuple. Okay, so the code has been modified to work with a tuple instead of individual variables. So here we have a tuple for Alice's account with the same information as before and the same thing for Bob's account. The functions now only need 2 parameters: the tuple, which has all the account information, and the amount that you want to deposit, or in the case for the withdraw function, the same tuple with all the account information and the amount that you want to withdraw. So the deposit function, instead of using the account name and account number variables, it uses indexing to get the name and the number from the tuple. And it also uses indexing to get the previous balance from the tuple. So that is done here as well. So overall, the function stays pretty similar. You just use indexing instead of the individual variables. Now for the return, since we can't change the balance in the tuple, we have to return a new tuple which will store the new balance. So after Alice deposits, or not just Alice, but after anyone deposits, the account name stays the same, the account number stays the same, but the balance will now be the new balance. So we return a new tuple with the same account name from the original tuple, the same account number from the original tuple, both of which we get from the indexing of the original tuple. But for the balance, we return the new balance. And the withdraw function is pretty similar. Whenever we need to use the account name or the account number, we get those from the tuple using indexing. And the amount is still its own parameter. And whenever we need to get the balance from the tuple, we also use indexing. So we can see that here as well. Now, if the new balance is less than 0, we return the original tuple. And that's because if the withdraw did not go through, then nothing in the tuple changed. So we can just return the original tuple. And if the withdraw did go through, we print out the original balance, which is at index 2, and the new balance. And we return the new tuple, which still has the original name and number, but now has the new balance. So when we call these functions, for example, when Alice deposits 400, we pass a tuple into the function along with the amount, and we store the return of the function back into her tuple variable. So her tuple will be modified with a new balance. And the same thing is true for when she withdraws 700. We store the new tuple into her variable. And the same thing for Bob as well. We store his new tuple into his variable when he withdraws. Now, when we run this code, which I have already done, we can see it gives us the same output. So nothing really changed in terms of how it works. It just works with tuples instead now. Okay, so using tuples still has a bit of an issue, which is that we have to use indexing for everything. Now, it may not seem like a big issue, but to someone who is just reading this code and didn't actually write it or have it explained to them, they might not know that index 0 is the account name, index 1 is the account number, and index 2 is the balance. So the code will look very confusing to them. In fact, even the person writing the code might get confused. They might forget which index is which, and it might lead to them writing the wrong code or having to go back and forth remembering which index is which property. So now we're going to look at another way to solve these problems, which is to use objects and classes. So what we really want is a way to store all the data about an account in one object, one entity, but still be able to give all those different properties a name so that we don't have to use indexing like with a tuple. Now, the way we do that is by creating a class. So since we want to store information about account, what we will do is create a class called account. And this is how you create a class for now. Later on in the video, we'll be adding some more stuff to it, but for now, all the class has inside it is the word pass. So to create an account, you use the name of the class, which is account, and open and close parentheses, and you store that in a variable name. So what this will do is create an account for Alice. So then what we have to do is give this account a name, a number, and a balance. So we say a1.name equals Alice. So what this is saying is that the name for account 1 is Alice. And we can give account 1 a number as well and a balance as well. And we can create an account for Bob as well using the same syntax. This time we call in Bob's account A2. So A2 equals account. This will create an account for Bob, and we can give this account a name, a number, and a balance. Now the deposit function and the withdraw function have been modified to use this new format of using a class. So it still has two parameters, which are the account object and the amount. But what it does now is, instead of using indexing, which you would do with a tuple, we can ask directly for the account name using the dot. So the dot allows you to get the property of an object. So a.name will get the name of whatever account that is doing the depositing. So we print out the name, we print out the number using the same dot to reference the number for the account, and we print out the amount. Then we can calculate the new balance by again referencing the balance and adding it to the amount that was deposited. So these three variables, or these three properties, the name, the number, and the balance, were specified when we created the accounts. Again, using the dot to specify the properties. So we print out the old balance as well as the new balance, and instead of returning anything, what we can do is change the balance of the account to the new balance, the same way you would change a variable to a new value. We can change the property, in this case the balance of the account, to a new balance. So we don't have to return anything, since it will directly change the balance in whichever account that we call the function on. And the withdraw function works in a similar manner. We pass the account object and the amount, and we reference the name, the number, and the balance whenever we need to, using the dot. And again, down here we can change the balance of the account by the same way we would change the value of a variable. And for this option here, where the withdraw did not go through, well, we don't need to change anything, because if the withdraw did not go through, then none of the information in the object has to change. So we don't need to do anything here. So then we call the functions. So since the functions don't return any data, they just directly modify the objects. We don't need to store anything from the function. So we can just run the functions. And when we run it, which I have already done, you can see it prints out the same thing as before. So this is how you would use classes and objects to solve this issue. So your first challenge for this video is to add a fourth property to both of these accounts, which is the overdraft property. So you would give Alice an overdraft amount, and you would do one for Bob as well. And what this will do is, if Alice's overdraft is 1,000, then she can withdraw up to $1,000 more than what's in her balance. So you would have to modify the withdraw function to allow for that. So right now the withdraw function does not allow you to withdraw more than what's in your balance. But with the overdraft, you can withdraw an extra amount equal to what the overdraft is. So your challenge is to add this fourth property to the two accounts and modify the withdraw function to work with it. So you can go ahead and pause the video and try out this challenge. So we'll now continue on with the video. So when we switch from using tuples to using the classes and objects, we introduced one of the issues we had before the tuple, which is that we had to specify each of these properties manually. Now, although we're not using a separate variable for each of them, we still have to do it manually, which is not very efficient, because if we had 10 properties, then we would have 10 of these listing out all the different properties. So let's look at a way we can simplify this, and it is done using what is known as a constructor. So a constructor is a special function which sets the properties of an object when you create it, instead of you having to manually set all those properties. So in Python, to create a constructor, you do it in the class, and it's a function, so you start with def, and the name of the constructor is always init. 2 underscores, the word init, and 2 more underscores. And the parameters of this function will be used to set the properties of the object. So we need a parameter for the name. So account name, account number, and account balance. But we also need a special parameter which is used to reference the object itself. So that parameter is called self. And it might be a little confusing why we have this, but in a while you will see. You'll be able to understand it better. Okay, and we don't need the pass anymore, so you can remove that. So let's try to see what this constructor function does. So it takes the name that we want for the account, the number that we want for the account, and the balance that we want for the account, and the account itself, and then it sets the name of the account itself as the name that we gave it in the parameter. It sets the number for the account itself as the number that we passed it in the parameter, and the same for the balance as well. So to use the constructor, we don't need this anymore. We can instead specify the properties here. Okay, so this would be the new way of creating an account object using the constructor. So how this works is, when we create a new account object, we specify the three properties that we want, which get passed into the constructor as these three parameters: the account name, the account number, and the account balance. And then the object itself will get supplied, and the account name gets stored into the name of the object itself. The account number will get specified into the number of the account object itself, and the same for the balance. So it might still be a little confusing, but just do some examples, and we'll look at some more examples as well, and hopefully it will make sense after you try it out a few times. So let's change this for Bob as well. So this is how you would do it for Bob. So the general concept of this is that you don't need to specify manually Bob's name, number, and balance, and for Alice as well. You can do so when you actually create the account object. And this is done using a special function called the init function. And these three parameters get supplied to these three parameters, which get stored into the object itself as the different properties. So if we run this code, it should give us the same thing as before. And you can see we get the same output as before. So we don't need to specify the properties manually anymore. We can use a constructor instead. Now, sometimes the property of an object, you don't need to put it as one of the parameters, and I'll show you an example of that. So let's say we have a fourth property called a charge. So we want every account to have a charge amount as well. Normally, we would do that by specifying a fourth parameter, which we then store into the charge property of the object itself. So when we create accounts, we need to specify the charge amount like this. So this is how simple it would be to add a fourth property. We just add it as a parameter, store it into the object itself, the property, and then add it when we create the accounts. Now, if the charge for everyone was $2, then we wouldn't want to specify it every time we create someone a new account, because that would be redundant. So instead, what we could do is, instead of using a parameter, we can just say that whenever we create an account, the charge is always $2. So we don't need to specify it as a parameter when we create an account. So this is just to show you that not all properties you need a parameter for it in the constructor. You can specify the properties directly in the constructor without a parameter. And it works in this case because everyone's charge is $2 for this bank at least. So your second challenge for this video is to add 2 more properties to the bank account. These properties are the salary as well as the overdraft from the previous challenge. And the salary, you would need to specify it as a parameter, but the overdraft, you don't need to specify it as a parameter. You can just give it a fixed value for everyone, and that value will be left up to you. So you can go ahead and pause the video and try to add those 2 properties to the account class. We will now move on to the final topic for this video, which are methods. So sometimes when we have a class, we also have some functions that are used a lot with objects of that class. In this case, we have a deposit function which uses an account object, and a withdraw function which also uses an object from the account class. So it almost feels like these functions should be part of the class because they're so closely used to it. And in fact, depositing and withdrawing are things you can do with an account. So it would make sense if we could somehow put those functions into the class. And well, we actually can. So if we cut these functions and paste them into the account class, this code almost works. We just have to change one thing, which I'll show you in a while. But again, just to go through why would we want to do this, is because we have this account class which has all these properties, so we store them in the class. But along with the properties, there are also things that we can do with the account class in the form of functions, which are to deposit and to withdraw. So it would make sense to put those functions in the class as well. Now, when you put a function in a class like this, the function is now called a method. And to use a method or to call a method, it's slightly different than calling a normal function. The first thing you have to ensure is that the first parameter of the method is the parameter which takes the account object or the object of whatever class the method is in. So in this case, the first parameter must be an account object, which it is. And the same thing for the withdraw function as well. So that's the first thing. The second thing is that when you actually call in the method, instead of putting the account object as the first parameter, you change it like this. So you change it to this format, where instead of putting the account object as the first parameter, you put the account object dot, then the method, then the rest of the parameters in here. So you don't need to specify the account object in the parameter anymore. And let's change it for these as well. And this is how you do it. So this is how to create a method, which is basically putting a function in a class because the function is so closely related to the class. And let's run the code just to make sure it works. And you can see it works. It prints out the same output as before. Now, another thing to note is that in Python, when you create a method, I already specified that the first parameter must be the object of the account class, the account object. And in Python, we usually change the name of this parameter to self because it references the account itself. So we'll change this from A to self. And because of that, we would have to do so in the function as well. Everywhere we used the A account object, we would have to change it to self. And the same for the withdraw function. And so this is the proper way to create a method. You have a function. The first parameter is the object itself, and you should call it self. And you have the rest of the parameters. And then when you call the method, you have the account object, then the dot, then the method name, then the rest of the parameters, which in this case is the amount parameter. So your final challenge for this video is to add in all the properties that we mentioned from the previous challenges, the salary, the overdraft, and yeah, I think that was it. Just the salary and the overdraft. And to create a new method, a third method in this class called monthly. And what it will do is calculate, or rather modify the balance of the account so that it adds the salary to the account, but it also subtracts the charge amount from the account. So the method would look something like this. So it doesn't need any other parameters. It can just use all the data from the account object itself. It doesn't need any extra parameters. So it will calculate how much the balance should change based on the person's salary and their monthly charge, and it will modify the balance of the account to add the salary and subtract the charge, and then it will print out the new balance. So you can go ahead and work on that final challenge for this video. And with that, thank you for watching, and I'll see you in the last video.